So today we're going to teach you how to calibrate a pH meter. And first you begin by plugging it up, plugging it in, like so. And then this is the electrode. You plug it in, there, like so. You cut it on. You'll take this out and screw it. Put it in the distilled water. Then blot it off. Then we're going to put it in the pH of 7 solution. Then we're going to go to, okay, hit calibrate now. We're going to calibrate now. And the known value is 7. There we go. And then it says volts, and then we're going to keep. And then you take it out, you stick it into the water, rinse it off well, and then you blot. Then you stick it into the second buffer solution, which is a known 4. And then after it reads the voltage, you hit, and then hit keep. Oh, there it goes. Alright. And then it's set, and then the sensor's settings are done, and you hit OK. So then you take it out, and then you stick it in this, and you blot it, and then you stick it into the known buffer solution, and you wait, and it should give you very close to 7. Alright, and this shows we tested with the pH buffer of 7 to make sure, and it gives you a perfect 7. And this shows we tested with the pH buffer of 7 to make sure, and it gives you a perfect 7.
This hand have a pH meter. This hand have a sample of acetic acid. They insert the pH meter into the acetic acid and take a value of the pH. And as you can see in the pH meter readout, it is ever changing, roughly 2.
Okay, so now we know the pH of our unknown. We're going to record that in our notebook. So pH 2.20, okay? That's our unknown. Okay, so now that we're finished using the pH meter, we're going to clean it. Okay, so we take our instrument here. It's very fragile, so we got to make sure that as we clean it with distilled water, which I have in a beaker here, that we do not hit the sides. Okay, so we're going to gently swirl it. Okay, we're going to dab it off. We're going to take our storage container, which we have right here. We're going to gently place the instrument inside the tube. Then we're going to, okay, and now we're going to unplug the instrument. And then we're going to unplug the instrument, take it and store it back where we found it, which is on the cart.
The difference between weak and strong acid dissociation in a solution is a chemical equation for hydrochloric acid and water, and how it dissociates. So you notice we have a single direction arrow here, and that's because that when hydrochloric acid dissociates, it's nearly 100% dissociation, and that's why it's classified as a strong acid. Now, weak acids such as acetic acid would have 2 arrows, and so it would have an arrow going this way and an arrow going this way because it's not a strong acid, it's weak acid, so it has less than 100% dissociation. Okay, and then ways to kind of minimize that, control your concentrations of what the chemicals that you put in, what substances you put in, very constant. And so what I've written here is the equilibrium constant for this chemical reaction. And so you notice that liquid is excluded from the equilibrium constant, and the reason that it is excluded is because that liquids and solids are considered almost incompressible in the form that they're in, and it takes a lot of pressure to even cause a change in the concentration. So the concentrations essentially are constant, and so we don't even consider those in the equilibrium constant. Thank you.